Hello friends, welcome back to the another video lecture of ADA subject. In this video lecture we are going to learn about linked list. So let's understand it by its definition. So linked list is a set of nodes where each node has two fields, data and link. So in data field we will store our elements value, and in our link field we will store address of our next node. We will have a node. In that node we will have two parts. First will be data and second one will be our address, or we can say link to the next node. Okay, so now this is example. So in this example we will have three node: first node, second node and third node. So linked list is the list of elements which are joined by the link, or we can say addresses. Here we have three values: 10, 20 and 30. 10 is the first value, or we can say head value. After 10 we will have our next value 20. So for that we will have address of 20 into node 10. Okay, so node's value is 10, but next, or we can say address of next node is 1500. Now next node is 20 and this is the address of its next node. So next node is 30 and 30 is the last element in the list, so address of next node will be null here. Okay, so this is a linked list. So for a representation of linked list in C we will need a structure. In that structure we will need two things. First one will be the data and second one will be our next, or we can say our address, or we can say our link. Okay, so we have created a structure and create a variable of that structure, that is node here. Now advantages of linked list. In linked list organization, insertion and deletion of element can be efficiently done. Second, there is no wastage of memory. The memory can be allocated and deallocated as per requirement. This is because of dynamic memory allocation. In dynamic memory allocation we have already seen that what is malloc, what is calloc, what is reloc and what is free. Okay, so these are the advantages of linked list. Disadvantages: linked list organization does not support random or direct access. You have to go through each and every node for finding your particular node. If your node is fifth node, then you will have to start with first node, after second, after third, after fourth, and then you can access your fifth node. So in that, random or direct access is not possible. Next disadvantage is each data field should be supported by a link field to point to the next node. You will need to store next, or we can say address of its next node. So these are the disadvantages of linked list. And we have studied in PPS, or we can say your C language, dynamic memory allocation, malloc and calloc function that we will use into this linked list allocation. Now basic operation in singly linked list are creation of linked list, display of linked list, insertion of element, deletion of element and searching of element. So these are the five basic operations which are applicable on singly linked list. Okay, so first is creation of linked list. So in that case we will create our linked list. So we will do new is equal to get node. We will call get node function. In get node function we will have node temp. Node means this type of structure in which your first thing will be store value and second thing will be store your address, which we have discussed here. Data and next means address. Okay, so this type of structure you will be there, and the structure will be empty at this point, means this declaration point. After it we are checking that we have enough space to that temp node or not by malloc function. If we have enough space to store this node, then we will give temp next is equal to null. Means in this node, in this type of node, first we will have this type of structure, name is temp, and after checking this malloc we will give temp next is equal to null. Means we will give here null value. So this is temp node. Now we will return temp, so which will reach here, and this temp will be become our new. So now this node name is new. Okay, so now we are getting new into data value. So we are news data part, means this place we are giving value. Okay, so this is the creation of linked list. We have created this node by using this code. Okay, so if our linked list is empty, so we will name our temp node or new node is equal to head node. Means if no node available into linked list, then our first node will become our head node. In previous data structures like queue, we have used rear and front. In stack we have used our top, but now in linked list we will use our head here. Okay, so this is creation of linked list. Now step number 3, if we want to add some node into our linked list, then what we will do, first this node is available with us. Now we want to add this node into our linked list. So simply what we will do that we will put this node's address into this null part. So we will link these both node. So what we have done here, this node is our head or temp node. So just simply we have given our temp next, means at this part address of new. So we can join both of this node like this. Okay, so now this is the head node and this is the temp node. Okay, if we want to add another value, if we want to add 30 here, so again what we will do temp next is equal to new. So by this way we can add 30 into this linked list. Okay, so here we have added 30. If you want to add 40 here after 30, so again what we will do temp next is equal to new, then we can add our 40 into our linked list. So this is insertion of node. Okay, or we can say creation of linked list. This is the display function of linked list. In display function what we will do, we have taken a temp node, we are placing temp node at the head node, means at the first position, but it is if null, then we do not have any value in a linked list. But it is not null, means we will have some values into our linked list. So we will execute a while loop till we have null value into our temp. So first node will be there, data value will be printed, and temp is equal to temp next, means we will move to the second node. Again we will print data, again we will move to the third node, again we will print data, again temp next we will move to the new node. But here it is null, means this condition is false, so we will stop here and print null. So we will print these 3 value by this while loop. So this is display of linked list. Okay, so we will display this 10, 20, 30 and 40 and null by this display function. Okay, now insertion of element into linked list. We can insert element by 3 types. First one will be insertion of node as head node, means first node. Second will be insertion of node as last node, and third one is insertion of a node after some specific node. Okay, so let's understand first insertion of node as edge node. Means we will have to add our node as first node. So what we will do, we will take two nodes new and temp. We will create a node by get node function, and that node will be new node. We will enter data into that new node, so simply it will be look like this. And now we will check if our head is equal null, means if we do not have any value into linked list, then we will say that for this created first node is a head node. Means if any node is not there into linked list, then our node will be the first node, or we can say head node into our linked list. But if we have some node into our linked list, then what we will do, then we will do that our first new node is here. Suppose here 40 is there, so what we will do, here is new and this is head. So what we will do, we will give new next, means at this place we will give address of temp, this temp. So we will give address here, and what we will do, we will declare our new node as a head node. Now we will give this a head node. So this is will be the first node or head node, this is second node, this is third, and this is fourth node. Okay, so this is insertion at the beginning, or we can say head node. Now insertion of node as last node. So again we will create node, we will get values of that node, and if we will check there is no value into our linked list, then we will give our node as a head node. First node and last node both are the same, only one node is there. But if we have some node into our linked list, then what we will do, we will declare this as a temp. And what we will do, we will run a while loop until we have temp next is not equal to null. Here we have not equal to null, here we have not equal to null, and here we have null. Then we will have this while loop is closed. Then what we will do, we will do temp next is equal to new, means this will be the temp at the last, and we will give temp next, means at this place. What the address of new, means we will place our new node here, and what we will do, new next is equal to null, means this we will put null here. So this is the insertion of node at the last position of your linked list. Okay, now insertion of node after some node. If we want to add our node after some specific node, then what we will do, we will process same if we do not have any value into our linked list. But if we have some value into linked list and want to add data after some specific node, then what we will do, we will take some specific value from the user, means after which node we are going to add the node. After that we are giving temp at the that node, and we will run a do while loop until our key is not matched with our temp's data. If we want to add data after 20, then we will move further to here, and if we find key is equal to 20, then what we will do, then what we will do, temp is equal to temp next. What we will do, temp news next, means we will have a new node. So news next will be temp next, means temp next is equal to 2000, so we will put 2000 here. We will do temp next is equal to new. Here temp next is equal to new. This will be cancelled and this will be done. Okay, so now 10, 20 after this node, and now this node. So we can add this node after 20. What we will have to do, we will have to copy this address into our news address, and we will have to move 20 to the new. So we can add our new node after some specific node by this way. Okay, so now let's see deletion of any element in the linked list. Okay, so for deletion we will take new node, temp and previous, integer key, temp is equal to head, integer null, link is empty. If our temp is equal null, means if do not have any value into our list, then list is empty. We cannot perform our delete operation. But if we want to perform our delete operation and we have some values into our linked list, then what we will do, we will scan a key, means which node we want to delete. After that, what we will do, we will search that key. So for search operation we will have this type of code. So temp is not equal null, then previous is equal to get previous, add and key. So here we will have two things, first will be head and second will be key. So if previous is not equal to null, then we will do previous next is equal to temp next and free the temp. Also we will have this condition false, then what we will do, we will do head is equal head temp next, means we will declare temp next is equal to head and we will free our temp. Okay, so basically what we will do, if we have two node into our linked list, first node is 10 and second node is 20. If we want to delete 20, then what we will do, we will give this is a temp. After it we will move to our key, means here we will give this a previous, prev means prev, and this will be the temp after moving here. So what we will do, we will free the temp, okay, and we will declare is a head node. Otherwise if we want to delete this first node, so what we will do, we will just give this is temp node and this is a last node. So just what we will do, head is equal to temp next, we will declare this is a head and we will free this thing. So this will be the node and this will be the deleted. Okay, so this is the deletion of element in the linked list. Okay, now searching of desired element in linked list. For searching we will have a temp node, a variable integer found, we will give head to the temp, we will declare this is a temp. If our temp is equal to null, then link is empty, we cannot do anything. But if it is not null, then what we will do, we will move to the next point until our temp is not equal to null and our found is equal false. Okay, so what we will do, if temp data is not equal to key, then temp is equal to temp next. If our desired element is 10, then we will do found is equal to 2. But our desired element is not 10, then we will make this node is temp. If our desired element is 20, then okay. But if our desired element is not 20, then what we will do, we will make this is a temp node. If our desired element is 30, then we will do found is equal to 2. Then this condition will be the false and move to the next. If found is equal to true, then we will print element is present. If element is not present, then we will print element is not present into our list. Okay, so we can find previous node also that we have already discussed into this thing. And now let's understand difference between linked list and array. So a linked list, each node having two fields, data and next, while array is a collection of similar type of data. In data is always stored at the same index of array. Second difference is sequential access only linked list, but in array we can access random. In linked list physical data can be deleted, but in array only logical deletion is possible. In linked list insertion and deletion is easy, while in array insertion and deletion is difficult. In linked list dynamic memory allocation and array uses static memory allocation. Okay, so this is it for today's lecture. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you friends.